So looking at this relationship between the number of toppings on a pizza and the cost of the pizza, I have it shown in two ways, as the table as well as the graph of the data. So the patterns that we can see in the table is if we look at the jump between the rows, we have a constant increase. So each of the increases in the number of toppings is +1. We have the same kind of constant increase in the cost, except we don't +1 on the cost, we add 0.75. So the rule for the pattern, we can talk about what the cost equals, and each cost of this pizza is going to have a fixed amount that we would have to pay no matter what, as well as an amount that changes with adding the extra toppings. So the fixed amount would be the $12, and the extra cost depends on how many toppings. Extra cost would be 0.75 times n if n is the number of toppings. How did we know to put it that way? Well, looking at the graph, we can see the cost is on the y-axis, the cost is vertical, so that tells us that the cost is the dependent variable. Number of toppings is independent. And whenever we write an equation, we always put the independent variable by itself. So the dependent variable goes by itself, that's why it's C equals. The independent variable goes with the calculation. So how do we tell that the patterns in the table get shown in the graph? Well, we look at the graph, the points make a constant increasing amount. They actually form a line. Now I'm not going to leave that line on there because these points actually should not be joined. Since we couldn't pick 1.5 extra toppings, that's why we have these points as a collection of points and not as a fully connected line. Last question, how we tell from the table that the graph is linear, that's where we look back at that constant change, that pattern we saw at the beginning. If the table shows a constant change, then we do have a linear relation. If that change differed, say we went +2, +3, +4 as we went from row to row, then we would not have a linear relation.